Today we're going to be talking about dilution. So in our first problem, we are told that we have 500 milliliters of a solution with a molarity of 0.5. And we want to know how much of the solute do we need to add to our solution in order for it to have a molarity of 1.5. So we have 500 milliliters. And we know that molarity is in units of moles per liter. So we're going to take our milliliters to liters. We know that there is 1 liter per 1,000 milliliters. And then we multiply by our original molarity of 0.5, so 0.5 moles of solute per 1 liter. And this tells us that we are starting out with 0.25 moles of our solute. So this is what we're starting with. And we're told that without adding any additional solvent, we want to increase our molarity to 1.5. So we know that we're going to end with a solution that's still only 500 milliliters, but we want it to have more solute in it. How much do we need to add? Well, our desired product is 500 milliliters, again, taking it to liters.
Oh, son of a bitch.
Can I...
Keep going.
With a molarity this time of 1.5 moles of solute per 1 liter. And this has 0.75 moles of solute. So this is our desired. So if we begin with 0.25 moles and we want to end with 0.75 moles, we take 0.75 minus 0.25, and we see that we need to add 0.50 moles of our solute. Now, in our next problem, we are told that we have 2.5 liters of a solution at 0.75 molarity, and if we want to decrease the molarity to 0.25, how much additional solvent do we need to add? So we're kind of working in the opposite direction, trying to decrease our molarity. So we're going to take our 2.5 liters of solution, and we're going to multiply by our molarity, starting, which is 0.75 moles of solute per 1 liter, and see that we are starting with 1.875 moles of our solute. Now we want to add only solvent, which means this number is going to stay the same. So what we can say, again remembering that molarity is equal to moles over liters, is that 1.875 moles over some unknown number of liters has to be equal to our desired molarity, which is 0.25. By solving for this, we get 7.5 liters. So we need to end with 7.5 liters. We started with 2.5 liters. So 7.5 liters minus 2.5 liters is equal to 5.0 liters. This is the amount of solvent that we need to add in order to decrease our molarity to 0.25. In our final problem, we are told that we have two solutions, both made from the same solute and solvent. The first solution has a molarity of 1.5, and the second solution has a molarity of 0.1. If we combine 1.5 liters of the first solution with 4 liters of the second solution, we want to know what the molarity will be of the resulting solution. So, first, we're going to take the amount of our first solution that we're told we're going to be using, which is 1.5 liters, and multiply by our molarity, which is 1.5 moles per liter. And this is 2.25 moles. So from our first solution, we're going to get 2.25 moles. This is from first solution. Now our second solution, we're going to be using 4 liters, and again multiplied by the molarity, which is 0.1 moles per liter. And this gives us 0.4 moles. So this is how many moles of our solvent solute that we get from our second solution. So when we combine these two together, we get 2.25 plus 0.4 is equal to 2.65 moles. So we will have a total of 2.65 moles, and we're combining 1.5 liters with 4 liters, which is going to get us 5.5 liters. And so, again, we just plug this into our formula for molarity, which is moles over liters. 2.65 moles over 5.5 liters is equal to, rounding, 0.5 molarity.